Good morning, all. Here we are on a Sunday at the shop. It's a nice day outside, nice spring day. We have an Indramat Servo drive, DDS03, DDS03.1-W0303-R. And the complaint is that this drive is powering up to alarm 84. Let's power it up and see what happens. Oh, look at this, is a little bit different. It's not 84, it's 83. Huh. Well, I'm going to hook a laptop up to this and see what the Indramat Servo drive is trying to tell us. Let me power down. I couldn't get the laptop to connect to the Indramat. The Indramat would not communicate with the laptop. Probably have to fix my COM cable. Wire might have come undone. But here is alarm 83 and alarm 84, and these are fatal errors. 83 is error reading drive data. The operating software reads data from an EEPROM in the drive controller during initialization. If this is not successful, the above message will be generated. Hardware error in the drive controller. Remedy: replace the drive controller. 84, drive data invalid. Hardware error. Remedy: replace the drive controller. Let's go inside and we'll see if we can fix that EEPROM. We'll get the right data put into it. It's a very difficult procedure because I don't have the programmer adapter to properly program that EEPROM. But you know me, I got ways of getting around that. Okay, here we go. Let's go inside. Take and measure our DC bus, make sure it's low enough so we don't get shocked. Well, there we go, 794 millivolts DC. I think we're okay. we are. We're in. Let's go find that E-square prong. Okay. Looks like we've been in here before. It's all new capacitors. Right there by the crystal. That's the E-square prong that we're going to remove and reprogram. If I've got a new one on bench stock, I'll replace it. But if I don't, I'll use the old one. Makes it a little bit difficult. That ribbon cable connector is right beside 4 pins, so it's kind of hard to get on. You don't want to melt that connector if you can possibly help it. But I'm removing surface mount ICs, or stubborn parts for that matter. I like to use this chip quick right here. Chip quick, part number SMD16. Now, the chip quick stays molten long enough for you to remove that part. First thing I do is I'll take some flux and we'll flux the pins of that IC. Get my tweezers. I have a pair of tweezers to lift that off the board. Here we go. Need to get my surface mount glasses. Come here, surface mount glasses. Where are you? Surface mount glasses are close up, close up. I have reading glasses, then I have close up glasses, and then I have surface mount glasses. Are we in the frame? I think we are. Get on there. Get on there. There, it's loosened up. Let me get my tweezers. And we have it off the board. See how easy that is? Now we have to clean the flux and the chip quick off the board and the old solder. So we'll use the solder wick. This is made by Chemtronics. Let me turn that around so I can get on. There we are. I like to add a little bit of rosin to the solder wick. That helps the chip quit to flow up into that solder wick when you add that rosin. Okay, I'm going to clean up the board here. We'll get the rosin, the old solder and chip quit cleaned up. And then I have a new 24 CO2 on this static foam. Right there it is. And I'm gonna solder an IC socket to the pins of this new IC, this new E-square prom. You'll get to see that in a little bit. That's a very difficult process because the pitch on these pins is very, very tight. Let me go clean up that board. I'll be back in a little bit, and we are going to solder. Let me see if I can get in the frame here. Back up a little bit. We're going to solder. Well, let me just set it down here and you can see it. We're going to solder this IC socket with these wires hanging off of it to the pins of that E-square prom. So we'll be able to program that E-square prom. People, that's crazy. Well, yeah, it is, but it works. We'll see how we do here in a little bit. Back shortly. This right here is going to be the hardest part of this whole process right here, and I'm going to use this block of wood to keep that IC from sliding around. I don't know if you can see it, but that's fine. What we want to do first is add some flux to these pins. Just 1, 2, 3, pin 4, turn it around. We'll get the other side. We're adding solder to these pins to make it just a hair bit easier to attach those wires. Hold still now. 1, 2, 3, and 4. Okay, come here. Okay, there we go. Now, I take my loop and make sure where pin 1 is because we don't want to solder this in backwards. Okay, there's pin 1. We're still in the frame. There's your flashlight. Yep, okay, we're on the pin 1 side. Pin 1 is right there on the left-hand side. Now the reason we don't want to get this backwards is because we have to set it down in the programmer socket. So, here's pin 4. Straighten that pin out. Oh no, oh no. Okay, pin 1. I'd have to get my jeweler's glasses out to see what I'm doing. Let's try to get pin 1 on there first. pin 1. Put something down on this IC to keep it from moving around. I'm going to set that block of wood on there. Might not be able to see what we're doing now. I'm going to get another block of wood to set on top of that one to add more weight. I'll tell you what, why don't y'all come back when I got this thing fully soldered onto this IC. I'm about to expend a few cuss words, and I don't want y'all to get, I don't want y'all's ears to catch fire from me cussing. Oh, shoot fire. Well, here, let's try it a little bit more. There's one side. Unbelievably. Watch the wires blink off. So there's one side. We're going to go to the other side and solder it. Let's see how I can do this. I'm going to have to figure out some way to do this side. Bend these wires right here. Hopefully they don't come undone. Let's put our weight back on that point right there. There we go. Okay, now right here is the IC. Right there. Now we're going to solder the other side of the IC socket to this side, pins 5, 6, 7, and 8. Alright, here's pin 8. Straighten that wire out. Set that down on top of that because it's hooked up in the air a little bit. Pin 8, 3 more wires. There's pin 7. Now if you're wondering where I'm going to get the data to put into this new E-square prom, many years ago I did the same thing. I had a good drive and I had a drive that tripped on alarm 84. I took the E-square prom off of the good drive. I copied the data after I soldered the wires on, just like we're doing right here. And I copied the data to the top max. Now, this is a resolver drive. So when you go pull your good data out of your drive, make sure it matches, because there's -R drives and there's -D drives, and you have to have -R match the data from the E-square prom. -R has to match. I'm going to add a little bit more solder to that. Has to match the drive that you're installing the data from. Just a little bit more solder. Get on there. Okay, maybe that'll work. -R with -R and -D with -D. You can't mix them up. Straighten this out a little bit. In fact, this is the IC socket and wires that I used. Okay, that one's on there, I think. That one's very close to pin 5. I don't think it's touching though. Spread that wire out a little bit. Okay, you have a gap now. Last one, pin 5. Do we have them? We have them all. There we go. There we go. That's what you want. 1, 2, 3, 4, 5, 6, 7, 8. Now we'll go down to the programmer. We'll program this previously saved data into this E-square prom. Manufacturer Atmel, part number 24CO2. Now let's set our E-square prom into the top max socket. Close-up glasses on, make sure that they're properly installed. Okay, that looks good. Now we'll go over to the program for the top max. Let's select our E-square prom. Go to Atmel. Then we'll page down until we see 24CO2. There we are. Let's go back up. Right there it is at the very top. AT24CO2 in the DIP 8 package. Now ours is actually SOIC 8, but we have it on that a wire wrap IC socket, and so we select DIP 8, dual inline package 8. Now let's go up and we will open up our file. Let's go to desktop. It's on the desktop, and let me hunt for it. There it is, IC32 E-square prom checksum D04D. Let's open that up. There's our buffer checksum D04D, so we know it entered the program correctly. Let's click on program, and if I wired it correctly, we should be able to verify. and it verified okay. That means that the checksum D04D entered the IC, and we verified it as the same checksum, so the data is correct. We'll read it back out, and buffer checksum D04D upon that read. So we have good data. Now it's always good when you save data like that, add the checksum to the file name. That way you can immediately see that we have good checksum. Now we'll go back to the bench. I'll unsolder my wires and IC socket from that IC, and we'll solder it down to the control board. We'll put the control board into the drive, and we'll see how it boots up. We'll see if we were successful. Maybe we will be, maybe we won't be. We won't know until we fire it up. Now let's remove the IC from our programming adapter. There's one side. IC removed. Hang on to this. You'll use it again. Now that alarm 83 and 84, that doesn't happen very often. It was just a long time ago when I had this happen, and I've had this ever since. I knew it would come back and help me out. Now bring the board up to the bench, and we will install that E-square prom into this board right here. Add a little bit of solder to these pins. That should aid us in installing that IC, especially since we don't have a whole lot of room between pins 1, 2, 3, and 4 in that blue connector. Should do it. Before we go any farther, make sure I got that in right. Okay. Alright, we are correct. Let me turn the board around and we'll get the other side. I did it. It didn't melt the connector. Now, let's clean our board up a little bit, and then we'll put this back in the drive and see how she powers up. that's everything except the speed reference. If it boots up good, we'll hook up the speed pot to that DDS03.1-W0303-R card, and that would go to the E1 and E2 terminals. Turn on the 24 volts for the DDS03.1-W03 card input. I'll move the camera over here to the drive 7-segment display, and we'll see what we get. Here we go. All right, folks. Good job. You fixed another one. Oh, man. Was that a grizzly bear or what? Good job, all. Good job. All right, I'm going to power down, and we're going to make this motor run. Good job. I had to repair the ground wire on my comm cable. It broke. Come undone from the solder connection. But I got the motor running smooth now. What I did was I lowered the current loop proportional gain and the velocity loop proportional gain KP. So I lowered those two values, and now it runs smooth. She's a sweetheart. All right, folks, good job. You got another one repaired. Let's go see who's next. Who we gonna fix next?